Let's look at number 22. How does the graph of g of x equals 0.5 cosine 2x differ from the graph of its parent function f of x equals cosine x over that interval? Whoa, what's it even asking? What's a parent function? A parent function would be a function that you start with and then you manipulate in some way to get the other one. So if this one is the parent, that one is the child, and you can kind of see, you know, like if you're comparing real people, oh, it looks like his dad, it looks like his mom, whatever. They obviously look alike, but there are a few subtle differences, so we want to know what those differences are. Obviously, what was an understood 1 is now a 0.5, and what was an understood 1 here is going to be a 2. And we've done this. We did it with sine and not with cosine, but the same kind of ideas apply. So let's go with it a little bit here. That 1 in the front affects the amplitude. So an amplitude of 1 versus an amplitude of 0.5. So f of x and g of x. Let's just make a couple comparisons. We're going to grab a calculator in a second and go with that. But this one has an amplitude of 1. This one has an amplitude of 0.5. And the calculator will show us that in a minute, but I want to just do a little bit in my head as at first, if I could. So let's see. How does the graph of that compare to that one? Okay, the amplitude of that compared to that. The amplitude of that is smaller than that one, so that means that it's either A or B. That rules out C and D. So now we have to determine the period. And while that can get tricky, I'm going to tell you first, and then we're going to graph it. So let's see. The period, that would be 2. That's the B right here. The period is not 2, but the 2 is going to help determine the period. And there's a 1 right here. So the period is always going to be 360 divided by that number. 360 divided by that number. Now in this case, they're in radians. They are not in degrees. And so it's not going to be 360, it's going to be 2 pi. So the period is, for this one, it's going to be 2 pi divided by 1. And, well, that's just 2 pi. If you really want a decimal for that, it's like 6.28 something. And in this case, the period is 2 pi divided by 2. Well, 2 pi divided by 2, the 2's are going to divide out, and you get a pi. So which one has a bigger period? 2 pi or pi? Well, that one has a bigger period, so that one is shorter. So the answer is going to be A. Now, if you didn't know to go through all that, you can graph it in your calculator, and that's what we're about to do. Because just because you know the answer, don't tune me out and don't turn the video off. I want you to follow along with this too, because this is going to come in handy if you forget some of those things. Press Y equals. Okay, first of all, the last problem I did on my calculator involved a scatter plot. May not have been for you, but I'm going to turn my scatter plot off, and in my case I can just go up and hit enter. But if you don't see that, then you can hit second and Y equals and turn it off from there. Let's press Y equals and let's clear some stuff out. We're going to graph, I like to graph the parent first because they came first. So cosine of x, and then we're going to graph the child, 0.5 cosine of 2x. And we need to do a couple things. First of all, again, the last time I graphed mine, I was on a really bizarre window range that dealt with scatter plot. And so we're going to press zoom. No, I just lied to you by accident. We're not going to press zoom. We're going to adjust our window. Let's adjust our window to be this. We want our x values to be between negative pi and pi. So press window. Our minimum needs to be negative pi. And notice how it gives you a decimal approximation here. And then the positive one needs to be pi. Now, what about the y values? I don't know. Let's see. If we were to graph this the way it is, based on what I have, we wouldn't see the whole thing. So we need to go a little taller on this thing. So let's press window again, and let's adjust this to be I'm picking a random number, negative 1.5 and positive 1.5. Now, again, knowing what I know based on what I've written, I know the amplitude is 1, so really I could have just gone from negative 1 to 1 and it would have worked just fine. But let's press graph. There we go. That's the parent. That's the child. Oh, and the question now, again, was how does G compare to F? How does this, the child, compare to the parent? Well, the child is shorter in terms of amplitude. Well, that narrowed it down to A or B, as we have already done. And the period. Okay, here we see it at the top, bottom, top, bottom, top. However, with the parent function, we don't see nearly as many cycles. In this case, we see 2 periods. Now, I'm looking at the child. We see a period here. We see a period here. But when we're dealing with the parent function, we just see it go from bottom, top, all the way back to the bottom. We see 1 period for the parent function, whereas we see 2 for the child. So for the child, the period is shorter. There we go. Because we're able to fit more of them in the same window range.